Hello everyone and welcome to the it's episode number 36 first game development. I need to clean my glasses first and open my thing here. Right, I can see now. All right, so today we're gonna work on freezing dwarves. I'm trying to fix my sound because I'm having some issues here. All right. So, what are we doing here? Needs data. Whoops. Added terrain here. So what's the issue here? Consumable, AoE, armor, item, body parts, terrain. Wait, what? Transform components. All right. Whoops, this is what we're returning. And because I don't want to always return it, let's put this as an option. For now it's always gonna return something, but I think I'm gonna change that soon. Whoops. Right. Putting a tiny note here because it needs some extra optimization. And here we will I wonder if I can just parallelize that though. So action type, action type, action type. Idle, and let's add the action type move to position. So if we want to move to this position, it's very easy. First of all, we need to This has to exist. Okay. And we're gonna say cell dot. But actually, we're not gonna say anything. So this guy needs to exist. What's this? Vector 3. All right. Do I need anything from here? No. Oh no, I need to assert. Maybe not, because something could happen in the meantime. So, let's say if it's a map cell, we need a property like is it in terrain? Create, add connection points, build site. It's safe to walk on. So yeah, first of all, we need this assert. So no, we can't assert. Can do this actually. Sorry, I'm a bit okay. So it has to be some cell, and then if terrain safe to walk on location, if it's not safe anymore, to do. So let's say somebody builds something on that location and you need to go there to get yourself heated up. You need to abandon this. Here, let's put the to do outside. Actually, let's do it like this else. So it actually crashes and reminds us what we need to do. Perfect. And not crashes, panics. Now we can just go what should we say? So if it is safe, dwarf set destination some. That's it. Other than that, we're perfectly good. If we have arrived, so do I have this here? Whoops, what am I doing? If dwarf position is not location, we're gonna set else the action is done. Other than that, this is not done. Cool. What's this? Primary weapon should always have an attack base, blah blah blah. This is not true anymore, so this is not gonna be enabled. Alright, so basically what we're doing now, we're gonna make dwarves find a hot place if they're freezing. So this has no entity that it refers to, so it's safe to just do nothing. Value assigned is never read. Interesting. What do you mean it's never read? Oh, Whoa, 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 not like that, not like that. So we're gonna consider what? What's this? Terrain. Right, so we didn't do any finding of that position yet, because I was actually in the middle of something. So, alright, so we just need to find a hot position, and we're just gonna do a like a expanding search from the dwarf's position to find a hot place on the map. And obviously this isn't super great, because at worst you need to search all the map. That's why I put this, but we're gonna do it a bit differently later, and we're gonna cache the hot and cold places. So if we have a candidate position, then possible but not safe. So what's it safe to walk on? It's not occupied by an item, and it's possible to walk on, it's just, but it might have an item. Alright, so this. If it's safe to walk on, we're gonna do we're gonna need the hot place. So what do we consider hot? So let's see here. Sorry, I have something in my... Alright. Let's put it... what is it? 273. Let's say it's bigger than 25 degrees. So let's say 300. To do actually all right. So what we're after is the closest place that is warm enough for the dwarf to get rid of his freezing condition. Therefore, I need to do another variant of that, which is immutable. So we're gonna say here, we're gonna break. Will we break? No, we'll not break. So we have the temperature. Wait, sorry, what was I doing here? If it's safe to walk on, set it as the candidate, and that's it. Push back. So here, and also Right. So we're gonna, actually this is wrong, so here we're expanding our search, and here we're doing the check. So if our current node is this, let me make it like this, then we just break. We found a good enough place, and we will set the position to B. This isn't current node, this is current position. So if we get the terrain cell from there, we get the temperature. The best position is that. This isn't push back, this is insert because it's a set. Blah blah blah. This position is immutable. We don't need the distance anymore because as we search from the, it's like a float field, so it's always going to be guaranteed to be the closest one when we find it, right? Through the way we expand our search, right? All right, so we're gonna do this. I feel like this isn't enough because we might want to search above and below from our places. So right. Because now it makes perfect. I mean, because the terrain is 3D, we also need to check above and below this. Like go up on ramps and so on in trying to find that place. So this is the height basically. Anyway, so we're gonna do this. Let's see if it builds. Probably not, because we still have a few. That's the beauty of, look at this. So we're gonna get an error that here we're matching on an enum, but we're not treating the new variant we added, which is beautiful because it kind of forces you to be thorough and change all the places where this enum action type is used, right? Now, it's quite interesting. So in combat, what is more important? Fighting for your life or trying to not freeze to death? Very interesting question, right? Maybe, what is it, warm up? Is it not? Oh. So not only do I need this here, but the reason is also important, right? Because we can move to a position for multiple reasons, and this is quite ambiguous right now. So maybe, can I match here on the, we have action type, and the reason is important, right? Action reason can be one of these, and if it's warm up, Makes me wonder, why did I go with putting the action reason as a different field? Because equip armor, equip weapon, it's gonna be the same reason. Not really, it's gonna be for combat or just the need of having something in your hand. Okay, so you could take an action type, which is this, and have different reasons for it, and here we're just checking this. So for now, I'm just gonna make a tiny note here. Right, because we might have this trade-off here. So if you're basically gonna soon die because of cold in the winter, there's no point in starting a fight because you're gonna lose anyway to the cold. You might as well try to run for a warm place and fight there. It's something to think about. Right now we're not gonna do anything and the combat will take precedence here. This is unused. Alright, so cool. What do you mean it's unused? Kidding me, it has to be used. Freezing level, we're gonna keep this warning. So let me see, because that import for game is used in a test, I was sure. Let's use it here rather than at the top, so we don't get cargo build. We don't get warnings. Did it compile? No, it didn't. There's one more place where this is matched for canceling actions, right? So what do we do when we cancel a move to position action? Do we need to release any items like this here? No. So we will just do absolutely nothing. I mean, we wanted to move there, but it's perfectly safe to not. Some of the actions reserve items, like I want to pick up that piece of armor, the dwarf reserve the armor. So when you cancel that, it will unreserve it, which is basically most of the things here. Alright, so okay, cool. It compiled. So what should we see here? We should see that once dwarves start freezing, which is basically instant because everything is broken now, bloop, they turn blue, right? They're gonna, what are they doing? Let's see, enemy dwarf. They're trying to get themselves heated up, but there's no... Just a conflict with something here. These, what are these? These are dwarfs, and these are enemy dwarfs. Looks like there's some sort of a conflict here. So I think that the freezing part from needs overtakes the need to fight, which is suspicious. We might have a bug here. So getting the needs action, right? Yep. Get equip armor action, get here. Who calls my get warm up action? We have a warm up action with this priority, which is maybe to Wait. So they should kick each other's butts, basically. Update freezing modifiers here. We have this thing happening, then we need to push the need here. Oh. Let's not do that, because I feel like... Alright, so they are fighting? Oh yeah, they killed everyone. So there's 3 of them left. Oh, no. Wait. Was I wrong? Did they... Sorry, I didn't... I need to check if... Wait, so these guys are all freezing. Oh no, they're all alive. And they're killing this guy. I should die here. Now they're just dancing between what and what. So it's cancelling the combat action. Dropping action, move to position. Then dropping action, combat. Right, so they're oscillating between these two, trying to get warm and trying to fight each other. I think maybe... So what's the... There's some needs here. Okay, so we're getting a need with some priority. Right, so what's the meaning of this thing? So we're gonna get the needs array, and then we're gonna sort them. I'm gonna return a candidate action. Right, so for combat we don't do anything. But makes you wonder. Maybe this is too high. Alright, so we're picking an action here. So we have some of it. And we're dropping the current one. And we're setting ourselves here. Right, but a bit dodgy because let's see. Let's attach ourselves and do a bit of debugging. So we're having a dwarf here and a current action of what? Of combat. Right. So we're dropping this in favor of our need. Which means, alright, this isn't great. So we could solve this in two ways. Now they're oscillating and the combat system says no, we need to fight, and this guy says no, we need to get warm, and they're remaining into this loop. Which I think will happen also if you get hungry while you're in a fight. Right? Because combat will the combat system here says that we have one enemy, we have a combat action that we can take, which is whatever. And here we're not gonna have a combat action if we're equipping armor, sleeping, or fainting. Otherwise, that thing overrides it. These two systems aren't really unified. So what we could do, we could basically check here. It's kind of ugly actually. I'd rather prefer all the actions get set and cancelled in one place, not in the combat system and then the needs system interacts with another. Because they're kind of both competing for the dwarves' attention, which is fine as long as everything would be competing in the same place, and then we can solve that with priorities. But right now it's a bit weird. So we can make combat a need that gets evaluated. So instead of like get combat action, here we're gonna have so we can do this here. So we have a needs action. Some of them have to interrupt combat. Not great. See, because it's kind of copy pasting this logic across, which isn't cool. You see the ugliness, so this isn't good at all. So action type, move to position. Actually, I'm not even interested in the action type, I'm interested in reason. So if the warm up, we don't do anything. And Oops, oops, oops. This isn't nice at all. Just put right, so this isn't cool at all. So then we can do this. Okay, we're gonna mark it. For this reason, is it copied? Please be copied. No, you're not. Okay. And then wait, this is the current action. So if this is combo, wait. So if the current action is fight, and wait, I learned today about one thing. Let me, well, learn this. I don't remember it, but we're gonna Google together. Match guards rust. This is quite. So match, and then we can put an if, and then we can do that. So this if needs action dot reason. Do they have EQ? Partial EQ is good. So if this is horrible. Really bad. So yeah, this isn't cool. So we need to remove this thing from here and move it into the actions. I think it's doable. Crap, it's not working. Did this work? Position idle, move to. Maybe this is how it used to work. I mean, it should be, because this is what I added here, and I'm just suppressing getting warmed up. And then just get combat action units, really. So if you have a new one, which isn't equipping armor, fighting, or what? Sleeping or fainting. Right. So then we're gonna try to get a And then we're gonna try to be idle, and then we're gonna fight again. I wonder why. Maybe if I move the way this never mind. Now these guys are just basically trying not to freeze. Problem with this thing is that they're not gonna even build a campfire because they're trying not to freeze. And also, this isn't warm enough, right? Because we said here that it needs to be at least 300 to be a good position. So this will be none. And then it will be some. And then we can do this. Else. It's always weird with these things, because right, so look how slow everything is now, because they're searching like desperate. So it takes a long time to find, basically. We're building it on top of this. They're still trying, they're trying to search for a warm place and they don't find it, and they're trying really hard again. Alright, so here we're gonna put a trick thing. Component, item component, blah blah blah. Where are you? So this will allow us to do something, which is first of all, once that fire is built, everything will just work. This is incredibly, so let's be a bit more conservative and put this like 10. Right, now we're building this campfire. Hey, Mr. Hazy, how are you? Now you can see these dudes hanging around the campfire because they are basically trying to get their temperature up. So we can see it in the, where is it? Even the cow, which is interesting. They're trying to warm up and they're sitting here because they're still frozen. Right, so this is pretty cool. They're never gonna be warmed up, but yeah. And now look, they're warm, actually. Which is in... Oh no, they got hungry. And hunger took over. And then they went, and now they're cuddling around the fire again. Get around the fire, what are you doing? Sitting near the cow. What? So I made the temperature, right? So now I'm having a pretty good simulation of temperature in the world based on physics. Well, kind of fake physics, but also real. So conduction is simulated correctly. So I get warm air near this fire and I warm the ground, and that works super nicely. So if we look at this terrain cell, it's like 290 Kelvin, which is minus 273, like 17 degrees here, which is hotter than here. Anyway, so we have that, and we also have a bit of radiation going on. So they lose heat and as time progresses. So now I'm trying to make dwarves freeze. So they're gonna basically, if they sit in the cold, and they're also naked, I'm not sure if you can see this, but they have like no clothes on, they will start to be frozen. And then as a consequence of that, they will try to move to hot places to get warmed up. So currently the way finding a hot place is, it tries to find the closest cell that's higher than 290 degrees, 290 kelvins, and they sit there, which happens to be right underneath them here. Because of this fire has a bigger effect. Because I didn't super tune the values due to the fact that the way conduction works in the real world basically is not fun. So if I simulate it with real world constants, it means that only this cell here, which is, I would say, 1 meter by 1 meter, would get heated from this fire, as well as a bit of the air around it. I also don't simulate convection, which is basically like movement of air and evaporation and stuff like that. So only through conduction is not enough to make this thing fun. So I'm kind of exaggerating how much the earth and atmosphere around this place gets heated up. So this tiny fire will also affect the area around here. But I think we're gonna basically go for a different approach, which is for the 10 cells here. So we're gonna abandon if we go further away than 10. However, we shouldn't break just because we found one that's bigger than 290. Let's find the best one in 10 cells. And actually this poses another interesting optimization problem, which is right now it's a bit annoying because as you will see, so they're fighting, whatever. I'm gonna build a campfire here because they're all frozen, right? That's why also they kind of turn blue, because they're frozen, you see. So they're building the campfire and they're gonna like cuddle around it now. Just okay. And they're doing this weird dance for some reason. Why are you doing this? They shouldn't do anything if they're still warming up. Couldn't cancel this. So they're trying to move. 790. What's this position? 970. Destination 1150. And then we get another one. Oh, because I know why. Right. Right. I think I know why this happened. So what they're doing is they're gonna, let's see the planning system here. So actually they're just moving to a position, and then they're saying once they arrive, they're very like, well, we're done, we arrived. So therefore, the needs system will say again, hey, dwarf, try to get warm, because now you're idling or whatever the new state is. So they should stay in that place actually. Why? I wonder why they don't. Actually, I think I know why, because this campfire will continue to hit these cells that have like a minimum. So they're basically constantly running around here, around the campfire, trying to get the hottest place. Which is... Well, we can do a hack here. Which is to say... that my need system will say the following. If it's bigger, do that. If right, they should just settle somewhere. Or anyway, this is kind of hacky right now, and the problem with this approach is that it does a kind of a search around the dwarf each time they're frozen. So you see everybody's frozen now. So okay, well, we're gonna try to warm up near the campfire. Warming up isn't yet simulated. So actually, when I say I simulate conduction between materials, and I do it only on the terrain. So terrain cells exchange temperatures correctly. What are you doing? You shouldn't sit in the actual fire. Nuts. Are you nuts? Anyway. Alright, cool. Alright. So now they're cuddled around the fire, you see? Boop. Including the cow knows to go there and get warm. But the problem with this is that you can have a fire super far away or so on, or actually have no fire, which means you're gonna search through the entire map in an attempt to find a suitable place to get your butt heated. Or not, which will fail all the time if you don't have this. So it will be the worst case scenario all the time. So we would like to short circuit that in a way. So now they got hungry, they went, ate some berries, and now boop, they're around the fire again, cuddling up here. So it's kind of working. So long story short, that's what I've been doing. Also, you might notice that the dwarves don't really get their color back. That is because they're losing heat too fast. So as I said, I don't yet simulate things properly, so they're okay. They're going, eating a baguette, eating a berry, with a cow coming back. Not great. And let's see what else is here. It's not great. So first of all, the performance issue, because we don't want to search just 10 cells around us, because the fire might be here, and when you're playing the game, you'll be like, what the hell? It's quite close. Just go there, right? So, and increasing that might or might not yield reasonable results, but I think everybody will still consider it a bug if they have a fire somewhere on the map, but not have the dwarves go there to warm up, they'll be like, why are you so stupid? So that needs to be solved, which I'm thinking about building this information on what's the hottest and coldest cell in a similar way which I have for my hierarchical pathfinding things. So pathfinding is a similar problem. So because I do it hierarchically, it means that this cell and this cell transitioning from here to here is kind of cached. So they know that these are transition points, and they know that. So it's basically having another layer on top of these tiny cells. So you don't have to search all manually and then backtrack here and then try again this path, and backtrack again if you want to get, let's say, to a corner here or somewhere. So they'll just jump through the big cells, knowing, okay, I can get from here to here to here through these entry points. So this is the closest to the destination, this is the closest to this one, and this is the closest to this one. And then from here to here, there's another mini pathfinding thing that happens as they move along in the higher level cell. So similarly to that, we need to cache for each high level terrain cell information about the temperature in that cell. So it'd be like the hottest place here is this, the coldest place here is this, or at least have a list of interesting temperatures that satisfy the minimum bar. We're saying we want hotter than this to be considered warm and lower than this to be considered cold. And if you have none of that, you'll be like, well, there's nothing here, so sorry, mate, there's no way you can get warmed up. So that's one way to optimize the finding of a warm place to warm yourself up. And the second thing we need to do is have a more realistic heat transfer between the entities and the environment. Because right now it's just interpolating between the old temperature and the environment temperature, which isn't great. So this needs to change, and it has to so they also need to generate heat based on probably how much they eat or whatever. But let's hardcode the thing that generates energy in each dwarf, so they have some internal heat being built up, and then that's the thing that will make them go back to their normal temperature, which is like that's how the human body works. You're kind of generating a bit of heat, and if you're losing more than you're generating, you're gonna freeze your body and die of hypothermia. So that's another thing that needs to happen. Like 295. So 295 minus 270. 22. So it's a bit exaggerated, right? So this 22 degrees here, and this is the ground temperature. Ground temperature shouldn't change that drastically. And also, I think we were in a bit of a problem here. So in the temperature system, shouldn't take the temperature of the ground. You need to take the temperature of the cell on top of you, which is the correct way to do it. You know what, actually this is also wrong. We need to do proper temperature transfer here as well, because also if you have that's probably not gonna happen, but the ground needs to actually more realistic, blah blah blah. Okay, actually this might be even better. So because the air around that fire gets heated way more than the ground, they probably can sit around it further away. But yeah, as I said, I need to find a way to optimize this and also get them more back up. So that's what we're gonna do today. Oh, by the way, I had that OpenGL bug, which was horrible. I want to talk about it a little bit, because I fixed it. As a reminder. Ah, it contains the spoiler here. Okay, never mind. So, let me show you the bug first. Maybe you didn't see it. I have this fragment shader. And we have this vertex shader, alright? I mean, really simple what's happening here. So we're gonna put this here. Alright. Okay. Comment this, don't use it here, and use this thing directly. And comment this. And let's kick off this thing. This is beautiful, actually. So it's quite easy. We're taking a color multiplier because I wanted to tint textures based on their temperature, right? So I'm gonna build here a campfire. Whoops. And now if we wait a bit, let me check my stream, because you should see sometimes these terrain cells flickering. But of course they flicker for 1 frame, so it's really hard to capture it and notice it on stream. Oh, you saw it? You saw something around here? Okay. So I got this flickering thing. And I spent ages yesterday trying to understand what on earth is happening. The way this thing works is actually it renders each of these line by line. You can probably see it flickering around here now. You see, you saw it here now. Right? It's super annoying and you're thinking, what the hell? And I did render doc captures, I did everything possible. At some point I just gave up yesterday and I was like, this is not working. Because I mean, I'm just rendering quads one at a time. Not even RenderDoc could capture the problem. Actually on RenderDoc I could see the correct screenshot with the flickering manifesting itself. So like I had a missing terrain cell here. But as I was running through them one by one through the commands captured by RenderDoc, of course, it would not reproduce and I would get my terrain cell here, right? And I was checking that my temperature is correct, that it's in this multiplier is in reasonable values and so on. So the way I fixed it, instead of having the color multiplier here in the fragment shader, right? Well, actually I can just undo. Oh, not too much. Okay, we're gonna redo it back then. It seems that I didn't close the editor, so it remembered everything. I was like, okay, so I'm gonna use it as a parameter here. And instead of multiplier with the uniform here, so I'm gonna make it a uniform in the vertex shader. I don't know why I thought that would work. And in the vertex shader I set it here, and this goes into the fragment shader, and then it's used here. Basically, according to the documentation of OpenGL, this makes no sense because the uniforms are shared between vertex and fragment shaders, and they even mention where is it? They even mention that if you give them the same name, they will be the same uniform. Guaranteed, blah blah blah. Anyway, they mentioned it somewhere. I'm not gonna look for it, but basically they're saying if you have a color multiplier here and the color multiplier here, they will get assigned the same location and they will have the same value. So basically it says it doesn't matter where you put it, if it has the same name, it will be basically working. However, the reality of my NVIDIA driver, thank you NVIDIA for this wonderful experience, is that somehow it smells like a race condition somewhere or whatever the hell is happening. They have a bug somewhere because it's unexplainable otherwise to me. So yeah, I fixed it, and if I put it like this in the vertex shader here, it will basically work and you will see no flickering whatsoever. So that's the story of my wonderful flickering bug that tormented me for I think 3 days. Right. OpenGL rant is over. Thank you for attending. Actually, it's not even OpenGL rant because yeah. I mean, I know I shouldn't probably render all these squads one by one, so I may have, maybe I'm hitting some sort of an edge case, where I'm setting the same uniform too many times per frame. Maybe they have some sort of a caching going on or some sort of extra buffers between. I don't know. I don't know how this works, to be honest. Yeah, but that was super annoying. Right, so these guys are cuddling up here. They're trying to find a good position to get their butts warm. They're sitting. So what temperature are you at right now? Well, let's take your hand. 297. 97. Okay, let's 297 means 297 minus, well, 24 degrees is good. So let's put here needs. Of course, there's a thing here that kind of bothers me as well. Yeah, which is here, don't hardcode. I have a bunch of numbers for the, whoa. Hello for, and thanks for the rate, honest Dan. And thank you for the follow, Nerdful. Yes, so, all right. Welcome, first of all, and I'm gonna explain shortly what we're doing here. Where I'm working on making these dwarves freeze to death and getting themselves back warmed up and not frozen. So we're gonna see what's happening here actually. This is this guy trying to warm up. Okay. So as you can see, they're going around the fire trying to get warmed up. Actually, I think I have a problem here. Let me put this value back. Oh, the cow also will try the same. So as you see, they're kind of turning blue, which is obviously what happens when you freeze yourselves. Also, they don't have clothes, so that doesn't help. So they turn blue, and they're fighting their enemies here, which look like them. and they're butchering them, whatever. This guy took a bucket to fight with the bucket. He's dying, alright. So now I'm building a fire here, and they will build it from wood, whatever. Lighting it up, and now they're sitting around the fire trying to get warmed up. Or so it should work, however, I don't see them doing that. Yeah, so this guy is idle. He's idle. Look at him. Idle, not a care in the world. Ah, it's pretty hot, so it's 3-0. Okay, now he's back frozen again, so he's gonna sit here. Alright. So they're kinda cuddling around the fire, and when they get hungry they'll go eat and then they'll come back. So I need to thank you for the follow, Merlin, the wizard. So yeah, as I was saying, this is kind of what we have now. In addition to that, I have kind of a pretty good system to propagate temperature from yeah, the bucket is very useful if you want to bake a dwarven cake, you see, because it's made out of 4 baguettes. Merlin the wizard will appreciate this. 2 strawberries and 3 units of milk. Exactly. I mean, they're dwarves. This is a traditional recipe. And oh, okay, but they're too frozen, and they're trying to get to cook, and then they're like, oh nope, too cold, and they're going back to the fire, which isn't great. So what should we do here? We're gonna basically hardcode this to 295 or something. Blah blah blah. There's a really nice to do. Alright, so that's what's happening. Also, we need to work on transferring temperature from the environment to the dwarves, because right now they just take the temperature of the fresh cookbook. I have French Charlotte cake, slices of bread around the outside instead of cookies. Alright, see you later. Cool. So now they're a bit warmer, even though they turn blue, which is quite interesting. Why did they turn blue? Wait, why are you blue? Oh, they turn blue because they're... Oh, look at this. My cat has visited me. Say hello, cat. The cat? Hello. Okay. What was I saying? Of course, I got distracted by the cat. Oh yeah, they're turning blue. Right, that's not good. So when are they're setting their color multiplier? Not here. Just go, not here. What is this? Ah, it's whatever. Oh, is this? Yeah. All right. So here we're freezing and we're setting the color multiplier. But this isn't good because Alright, so this is not good at all here. I did it yesterday for fun, so we see that they get the proper effect. So they they freeze basically. But this is not correct. So what we could do is we could, when we update the temperature, we should also update the color multiplier maybe, or whenever a dwarf gets back warmed up, they will, let's hard code it here, of course. It would be nice to be like a transitional effect, right? From that's depending on temperature. So that would mean in our temperatures propagation system, here we have an item component, a transform component. You know what? Let's do it here. Why not? Why not? Why not? So instead of doing this, currently we're doing nothing here. Let's put it here. Our rendering components, here we're gonna do, we have a transform component. We're setting the temperature of our item. We have this wonderful to do to have a more realistic transfer, which we're gonna do in a minute. But for the fun of it, we will do are you using stable or nightly? Have you tried any of the stabilize async functionality yet? I am using stable, I think. What was the command? This? So yeah, so I'm using stable. But yeah, sometimes I use nightly. Yeah, I use nightly for. I used to use nightly recently because they had that the build timings or whatever the name is. So that would show you a super nice graph when you build on how time is spent there. And I don't use async at all yet. And I have time to look into it, and I don't really know how I would integrate it with. So I don't yet have anything that communicates with any sort of a server or stuff like that, which would be a really nice candidate to try it out. Like, for example, sending some statistics or reading some news. When you start the game, you can read some news and display them at the bottom. Hey, this version has this release notes or whatever. It's a really good place to put async await in. Right now, the way I do usually when I have to do stuff in parallel, I just use Rayon and the parallel iterators that that library comes with, so which is very convenient actually for me. But definitely I want to learn a bit more about it, and I'm kind of postponing it because I looked at Tokyo or whatever you pronounce it like, and also STD async STD than you think, and I was a bit put off by it's wonderful when it works, but when it doesn't, the error messages are just awful, especially with Tokyo. I was actually yes, yeah. So once I introduce a bit of stuff like having news when you start or giving feedback or things like that, reporting bugs, definitely I will integrate with async things. Okay, so here this will be guaranteed to exist, because otherwise, yeah, actually no. The other way around. If you have a rendering component, it's guaranteed you have a transform component, but not the other way around. For no reason whatsoever, but let's do the check anyway. So actually it would be nice if we could how should I express this? So it interpolates from red to blue. Means I should interpolate between like this. Wait, what am I doing here? Trying to interpolate between two colors based on temperature. So if the temperature is tiny, we will get this cold color, which is red will be this, or actually I have color here, so a warm color. Also, it's interesting, another thing about async IO, which came up in the Rust game development working group as well, because it is all these systems basically, it's unclear, at least to me. Some people know more, but it's unclear how you can make them cooperate a bit better. So if I have Tokyo, it will have its own thread pool, for example, as well as Rayon will have its own thread pool. Which, to me, it's a little bit weird if I'm mixing these two systems together. Because it would be nice if they could share, for example, that thread pool between themselves. I think it is possible, but definitely I didn't spend a lot of time thinking how to do these things properly. I'm not sure if it makes sense what I said, but let's put it here. Because they're quite opaque, although I'm sure there's a way to configure them. But for example, you go here and you're like, okay, pathfinding. So pathfinding for me, actually here we're in temperature stuff, so we can even look here. So my temperature works on multiple threads, and each terrain level is basically a different, well, not necessarily a different thread, but it's a parallel iterator, and this work can happen in a thread pool. But basically I'm just using the default that comes to Ryan, which is the thread pool will have the number of worker threads equal to the number of CPU cores I have, I think. Something like that. So yeah, I do know that async stuff is usually for parallel waiting and thread pools are for parallel workloads, but you know, it's unclear how they could communicate, or I mean, it's not super clear to me at least. So the worm color will be, that's not, so this is red, green, blue. 2. And we should build a, I don't have, don't worry about it. Why do I have two helper modules? One with vectors, one with color. It's just... So... Well... The maximum range you can go to... I try to do this. I want the T, which is from 0 minus whatever, actually, yeah. Okay. This should give me, I think, the amount of... What's the default here? Of course. It's not what I want. Do I not have a default? Whatever, and we can do red is lerp. Call color. I should make a function to interpolate these red, blue. Right, anyway. So let's do this hacky thing. What? What are you talking about? What are we talking about here? Cannot borrow. Consider changing this to accept closures that implement FN mute. How is the syntax for this? Yeah, I'm considering it, but I don't know the syntax, so Google to the rescue. I think that I need to put a mute somewhere, maybe here. But also let's Google. Right, one answer, blah blah blah. Come on, really? Oh, capturing the environment. Okay. Change the environment. Okay, so how does the FN mute? Is it move? What? Not move. Because immutably borrows values. Yes. When you create a closure, resting first, blah blah blah. Wait. What am I doing here? Of course. So of course it didn't work because I was iterating through those in parallel, and for each of the item components I was setting a temperature which is fine, but also I can't write to the rendering components from this closure, so yeah, anyway, I had to remove that parallel thing. Alright, so let's see how this works. Alright, so these are warm. They're all on fire basically, so if I'm making a campfire here, also they're kind of frozen, so what's their temperature? What's this? It would be blue there, but I want it to be blue at what temperature did I say they have? 28030. This guy's temperature is, let's take a hand, 289. So 289 should be bluish. 80 should be the maximum blue. And I think I need to divide here by something smaller, and I also where is this defined? Okay, great. The min value, max value. All right. Enough of this hackiness. We will. What? Really? I don't need partial order. I need this. God. I just don't like whatever. So where is this even used? Oh, okay, I just used it on. All right, whatever. You know what? Can't be bothered right now. Okay. Right. Where is the rendering component? Item. Renderable. Color multiplier. Red is 2, green is 1. Is considered warm at 288. Really? 0. No, I don't understand why this doesn't work. We're just gonna good debugging. Right, color. Let's see here. 1. Oh. Oh my, not like this. Alright, so we're gonna take the new temperature, and I think this number might not be correct. Whoops. Because it's kind of too small for 287, so of course this 1.5 already. Because this interval is super small. Whoops. Anyway, this needs to be lifted out of this place, but I just wanted to see them. All right. What's your temperature, dwarf? And 297. So here, of course. Kind of went down the rabbit hole with this thing. Because we're already past. Let's make it red at not here, maybe 25, something like that. All right, so they're kind of getting warmed up, and then they're minding their own business. And then they can, I hope, craft, because let's see. Oh yeah, you see, well, still not enough. So they are basically freezing themselves, and then they're like, whoop, I'm not going there, going back to heat myself up, and then they're going to get that baguette, but they can't. Quite funny. So first of all, let's not be that drastic with when we're freezing. So we should be treating these with various degrees of... This is the dwarf core temperature, which is 295 degrees the kelvins, which is 22 degrees. So technically now it's actually not good for them. The reason we're reaching 22 degrees this fast is because of this code here. So if we're interpolating slower, oh man, I need to do a pass through all these constants that I hard-coded everywhere and lift them up of like we did with components and stuff. So here, and actually each dwarf should have a his own way of dealing with temperature and stuff like that. So maybe some of them have a bit more cold resistance. All right, but this is I can see how this could be a useful view. What? Oh, we crafted a roasted leg. Jesus, not a roasted leg. We need to build a cake here. We're like a happy bunch. Not savages. Alright. This cow is getting warm here. This dude is taking some stuff. Really? What's your temperature? Okay. Okay, this doesn't make any sense. We should just stop doing this and do some proper physics now. So this is not how temperature transfer works. Also, they need to generate temperature by themselves because that's how things work. Oh, so they're starting quite frozen because I think... Well, that's why we see this tint going warmer and warmer. Right, but if I'm telling you to basically build me this cake, dwarf, what the hell? Alright, so they're building a cake. Cool. These are just chilling here. Doing what? What are you guys? It's getting warmed up slowly. Taking some food break, freezing their butts. Okay, chasing the cow. For milk. Alright, so they build the dwarven cake. Cool. Let's not make this effect as bad as it is here. Right. Oh yes, heavily. But I actually... No. It is very similar from what I can see to Dwarf Fortress. I never played Dwarf Fortress. I played only Rimworld and Gnomoria. It's heavily actually inspired by Gnomoria rather than Dwarf Fortress. But I kind of read about it a little bit. Because actually Rimworld and Gnomoria themselves are inspired by Dwarf Fortress, but I couldn't get into that game because of the wall of complexity you're hit with when you start. And I just gave up each time. I tried it a few times. So, yeah. So we're doing here, what we're doing here, we're doing some sort of a transfer between yeah, I think it's quite a common theme because of that. I have my own theory, which is that people who are patient enough to learn Vim are usually patient enough to learn Dwarf Fortress. And on my sample of people that I asked them if they play Dwarf Fortress and if they use Vim, they're basically in the same set of people. So I think I'm onto something here. I couldn't get into Vim either, just in case you're wondering. However, so Dwarf Fortress also simulates a lot more things than just the colony, so it makes an entire world and history and all sorts of things. Here, I'm just gonna create some terrain, and you're gonna play in that random terrain with your dwarves and have all sorts of things attack you. Maybe some nearby colonies trying to trade with you nearby, but they'll be like fake. Which you can't visit, they'll just send emissaries or things like that. And also they will not have feelings, these dwarves, which might sound harsh, but that's the thing that I didn't super like in Rimworld, where I think I talked about this yesterday as well, where people just went crazy without much reason, and it was really hard to control, and they were like killing your colony pet or whatever just because they were bored and had no yeah, they went into like a stabbing spree, which just it was super hard for me to. I mean, it generally it's funny moments, but it's hard to enjoy for me. So it's just gonna be pure survival, no feelings. I mean, they just cooked another dwarf's leg, so can see that already. Alright, so I have here this logic that transfers temperature from one terrain cell to another terrain cell, and it also transfers it from so this is like a 3D Minecraft world actually, where we have also air cells as well as ground cells, let's say, because that's how the terrain is generated. Which probably until I get the isometric way of representing this terrain, or a nicer way, but this is top down, so it's hard to get a nicer way. But these are levels, so this is the bottommost level, this is a bit higher, and this is even higher, and it's basically randomly generated. Okay, it stutters a bit because I have some issues now. Whenever there's no so above land, we have cells that are air. So those cells we simulate temperature for them and temperature transfer between cells. And that's through these magical formulas that I got from a few books and some theory about thermodynamics. We're canceling a lot of actions here. Yeah, because they're not getting warmed up, so that's the thing. I need to change that action type. But as realistically based this is, the way that item components get their temperature is they just look at the air temperature in the cell that they're in, and they interpolate between their old temperature and the temperature of that air with this factor each time, which isn't great, as you can see, because it limits us, and it limits us due to a series of reasons. First of all, this doesn't take into account the fact that you might be well insulated and have proper clothes. I mean, yeah, they're naked now, but they can have clothes, so they have the ability to craft clothes. Also, it's quite, yeah, quite not realistic. So let's build a campfire here and then build a, they can build a loom and then they can craft stuff at the loom once they'll get like heated up. This guy baking himself in the fire. Right, so anyway, I want to lift these formulas outside of this terrain simulation for conduction, temperature conduction. So what we're gonna do is maybe just lift the formulas away, which is right. Let's do this. So let's take this temperature. Sorry, this thermal energy conducted is gonna be its own thing here, its own function, because I want to reuse them here. So the reason we're doing this so I can have the same formulas apply to both items in a cell and between cells. Whoops. Energy. Let's not transfer this, because it's not the only way we can transfer energy. So we need area. We need the time. We need the temperature difference here. And we need the thermal resistivity of the material we're calculating this from. So it's gonna be as well as wait. R value. Let's use the R value actually. R value, because the total resistivity is basically your material times the distance towards which you're gonna measure the temperature at the end, basically. So it's one thing to warm 1 centimeter away from the edge, but there's another thing to warm like 1 meter away from the edge of some, I don't know, material. It's quite important. So for example, for the terrain cells, what we consider the temperature of one cell is basically in the center. And this is gonna give us a value which is some in joules, which will be another floating point value. So this is basically this formula, which is area times time times temperature difference divided by the R value. Right, easy. All right, and then we can play around with these resistivity values as well as other things. Because once we have some energy, we need to how do we do this? Compute. So the new temperature will be calculated like this. Okay. So we need input energy in a system, the specific heat capacity, should I name them after QC? QC, and I mean initial temperature. And this will give me my new temperature. Turns. So this returns Q over, I also need a mass. Or whatever. So we're gonna get this, right? So here, instead of doing this, we're gonna do this. What's the time? What? Oh, it's not this, the other one. Compute new temperature. It should be the same thing. All right, and here instead of doing this, energy conducted will be get energy conducted for area, time, temperature difference, and the R value, which is our value. This temperature difference, though, I might lift this and calculate it here, so we don't get confused what minus what is this difference, because it actually has a sign. So we'll put on temperature and we'll put maybe other external temperature. So the difference is the external minus on. Of course, we can always get confused about this order and still screw it up. It's not like we have a huge ton of protection, but at least, you know. The neighbor cell minus cell, because we will receive, if the neighbor is hotter than us, we receive temp energy, or we give away energy if the neighbor is colder than we are. All right, cool. This is good. On, so it's external minus on. But internal. Right. So let's leave this here for now and run the game and check that we didn't do any tiny mistakes. Looking at the code, we basically copy pasted some stuff around, so we should be fine, but double check. It would be nice to have tests for this, but I didn't write tests yet. So we're gonna build a campfire. Right. This looks reasonable, I would say. Right, it's heating up. So, and this is actually the ground heating up, which is quite a huge ratio right now, so I need to tune that up. The thing is, as I was saying before, even if this is basic, where did that guy disappear? Anyway. Look at him appearing there. Alright, so there's another thing. If I just simulate, and I got some proper values from various like engineering books or whatever, or what's the thermal resistivity of air, of 1 square meter of air and stuff. The thing is, if you make a fire as big as this one, you'll just have to kind of cuddle around here for it to be efficient. Like 1-2 meters away, and then maybe a little bit here, but not in the freezing. If it's freezing outside, this area here does nothing. Thing is that that's not super fun, so we need to play around with those constants so that this fire has a bit of a larger effect and also heats up more air around it here. And we're kind of exaggerating even the terrain temperature, because technically this is 1 meter by 1 meter by 1 meter of soil, and it basically shouldn't change temperature at all if you have a fire here, or very little, especially where I measure it in the middle of it. So it's kind of physically based, but we need to make it also fun. So, however, making it based on actual physics gives us some good starting point for tuning some formulas, as well as realistic formulas, which is quite interesting. It's quite good. All right, maybe R value, we should have a formula to calculate this somewhere. Resistance of material times the distance. All right. Well, cool. Now, another thing is, all right, let's do this and I'll tell you what the other thing is with the constants. So these are fine, this is fine, we copy pasted them out, this is some note. And this is the distance of half of unit Celsius, we need temperature in the middle. All right, this is good. This can stay hard-coded because this will not really change. Because it's basically what's the meaning of a cell of air, the temperature of a cell of air. All right, and we have some, what is this? C value. It's the specific heat of that material. All right, cool. I got a bit sidetracked because I wanted to say something. Yeah, so all our items, the way I define items, I put them in this JSON file, and I put them in the following way. So they're basically, this is a list of recipes, and this is the entity type, and this is the recipe for that entity type. So for the campfire, you can craft it, okay? You can craft it where? You can craft it anywhere you want. So at the destination, where the command is, you saw me right clicking, said like build me a campfire here. You need the following item list. Some items need to be crafted at some proper workbench. So for example, the dwarven cake needs to be made at the cooking table. This is the list of ingredients, the count of these ingredients. All sorts of options are missing from this particular recipe, but you have like spawn additional things like side entities and so on. And we have the list of components here. You may notice that nowhere does it say, maybe for the campfire it makes no sense, but even for the bucket, it doesn't say what material it is. And all this thermal energy transfer depends on some constants that are based on material. I think one thing we need to add is this information to our entities. So we know when we calculate the energy transfer here, we will know both the mass. We also need to know the mass of the item as well as the material of the item. And maybe volume, but that could be maybe hard-coded, because we need all that information somehow. So for example, this empty bucket is made of iron, and iron has completely different thermal conductivity compared to whatever, air. And resistivity, which is way less than air. That's why you have like air in your windows to isolate temperature better. So I think we will need to add a field in this item component, which is basically material and maybe some material properties on it. Because the item component right now contains the temperature. It's not mentioned here because it's something we compute at runtime, but the properties needed to calculate this temperature should be inside here. And then we have like a renderable transform component, armor components, whatever. If you can hold stuff in the bucket, it has to be an entity holder, and that's it. Right, so what else should we do? Right, so let's hardcode a few more things here before we leave them here in this JSON config thing, as well as the settings for each material need to be in another JSON probably. So like the thermal resistivity of land, of ground, of air, or all of those things need to be tunable from outside the game. All right, so that side discussion happened, and now we're gonna get back here, and instead of doing this lerp here, now let's leave this aside. So this is of course just hacky to do fix this or whatever. It's so obvious that I don't even need to write a to-do. Should be some sort of a debug view. All right, so going back here, what should we do? We need to calculate the new temperature, so we need to properly calculate it. So one game tick is 5 minutes, I think, or 1 minute. I need to check. Actually, it's inconclusive. So let me see here. Where's the time? Blah blah blah. Thermal resistivity. This. Right, let's put this here for now. Like 300, it's like what, 5 minutes. So, all right. One thing we could do actually, I was thinking about this here. We could just have the mass and the material type, and we can calculate the volume based on that actually, because of course you can actually determine that to have less aberrant data here. Anyway, less chance of screwing it up by writing things that cannot possibly be real, like because you have like density, so that can be just a table. All right, so going back here, the new temperature will be the transferred energy. All right, so this is the area. So this is where it gets tricky. This is the surface area. Because then we can consider them for the purpose of the thermal simulation. Everything is a ball. The dwarves are a ball, every item is a ball, and then you can get this. So surface area here for the human body. It's like what, 1.5 to 2 square meters, which will be for a dwarf about half. All right, 1.5 meters. This doesn't matter for now. Time. Time on temperature, external temperature, R value. Yeah. And because if they would be all considered spheres as far as this energy simulation is concerned, then that distance is basically the radius of that sphere, and also that's why I'm kind of a fan of having just a mass here as well as a material type, and then we can consider them, they're just spheres of that mass. All right, so our value would be, what did we say our value is actually? Resistance of material times the distance. So the distance would be very, very small, which is this in, it has to be meters because we're in the international system, like 5 centimeters. So let's put distance here. And the first one, which I keep forgetting it, not resistance. Where did I copy this? Actually, let me search here so you guys can see what I'm doing. Of course, we can. Is this not? Ah, it's scan. Great. Okay, cool. Blah blah blah. Hey, get. Be good. Thermal resistivity, not resistance. It's important to get our terms right, because then we'll forget. Actually, this is okay. There's another thing that you need to sum up, and for example, if you have, right, so the total R value is, you need to sum all of them up, multiply by whatever. So this is for things which are made of multiple materials. We'll care about that, we won't care about that. Okay. Yeah, so this would be, where was the table? Sorry, I got a bit distracted, but I need it for water. What? Water. Lumberyard unit, okay. 1.6. Why water? Because this is what we are made of, so. All right. What's this? Wait, what is this? It's 20 centimeters. 10 centimeters is better. Yeah, let's say they're a bit more square, so like 10 centimeters. Like this. All right. This is the distance. All right. So we did this. We have the R value now. And then the new temperature is this new function, compute new temperature. Be cool actually in a nice way. So the Q. Mass? How big is a dwarf? In grams. Is it grams? It depends what value C is in. So let me take a look at the mass in grams. So Q is the energy, sorry. So this is transferred energy. This is a constant that I need. What else is mass in grams? How big is a dwarf? 30 kilograms? 40 kilograms? This is big. Oh wait, I need the grams here, and I also need the initial temperature, which is the temperature. Maybe I should make another formula that takes all these parameters and spits out a new temperature. What? Are you confused, Rust Analyzer? What are you doing? Okay, no, you're not. C. And this is the specific heat capacity of water. Which is... Okay, come on, water. Joules per kilogram per degree per kilogram, so it's 4.2. Or is 4,200. Ah, God. All right. Can I see them written in a normal way? $4,200. Okay. All right. Temperature equals this times this. And now we need to check how this looks like. Well, this wasn't too hard. Of course, these constants need to get out of here. So let's see. Another thing that happens here is that the dwarves get heated from the environment, or they lose temperature to the environment, but the environment will not receive that temperature, which I'm perfectly fine with, to be honest. It's, for our purpose here, I think it's just fine. You get into things like if you're in so I also don't simulate convection, I think it's called, so it's fine to just lose that energy or just receive it and the environment will not lose it. Let's be... Well, let's get the torso, right? Oh... So each of the dwarf body parts needs to have its mass in place. Because now a hand and the... Also, all the other materials are basically water, because as you can see here, all the item components for everything get iterated through and changed. So basically I'm considering all of them made out of water with a size of a dwarf. So that's not good. However, this temperature is 0. So this is not good, is it? Why is it 0? I might know why. Because they're born with 0 Kelvin, which is not a great temperature to be born at. Let's actually make them warm when they're made. What is it like? 28, 300 is fine. At 380, that was like, whoa, 100 degrees. Okay, and then we need to move these constants because they're really, really bothering me for being here. All right, so they're warm. They're warm. All right, so they're getting colder. So let's check here. I'm having 299 degrees. So 299 minus 273, about 26 degrees Celsius. And the terrain cell I'm sitting on is about the same temperature, 299.9. What? Why is it so warm? Oh, wait. So this is the terrain cell item component, but I should be looking at this temperature, 288. So here, let's take this dead guy. So he's slowly losing heat. Because... So this is 288, 299. So he's about 26 degrees and the temperature around him is 15 degrees. And this looks plausible, I would say. Also, the temperature is measured in this, so he's like a sphere of water. Sphere of water of a size of what, 0? Maybe the numbers. Maybe it's actually too fast. Oh no, actually. Yeah, so it looks reasonable actually. Thank you for the follow, spacecraft engineer, and welcome to the stream. All right, so okay, whatever. So we're having some. I think for now everything looks perfectly fine. I think here the surface of the dwarf, the objects, so let's say the dwarf skin surface, area surface, as well as the distance that I measured the temperature at is basically most likely wrong. So, because I'm not sure if your area is half a meter squared. What was the surface area of the human body? .5 to 2 meters. But I mean, we said that for this simulation we'll consider them spheres because it's easier like that. Anyway, so these numbers can get a bit better in the future. I think I made them too tiny, that's my point. Okay, so let's see them die here. So they basically should die, should get cooler at a faster ratio, which seems to be true. Because there's more surface area and yeah. Alright. You know what I didn't do? And I think this is gonna be a bit unpleasant. I didn't... Alright, so this didn't happen for a long time. Which isn't great. So let's put this in, because I think this is an independent change, so it will be... No, it's not, because it needs this change. Not this, this, and then it's this. Okay, let's add everything together, whatever. I wanted to do smaller check-ins, but I actually got carried away and didn't do any sort of a intermediate check-in, so now I need to push everything into this. Move to position. They get spawned and okay, coding stuff. A new function, move to position. Move to position needs to be deleted, and that's what we're gonna do next. Right before that, we will make a table of densities for each material. We'll make a material property for our item components, and we will make a mass property for our item components. And then we can have volume and everything, and even more accurate temperature transfer between items and the environment with minimal work. Because I mean, just putting a mass in there and having a table of materials and densities is quite easy. Alright, let's put this one too. Just skimming through all these changes to make sure nothing horrible. Yeah, this is horrible actually, but I'm gonna check it in anyway. Transform components. This is a branch, so it's fine. Okay, find me these things. And also getting warm-up actions, blah blah blah. Cool. I think here. Oh no, I do. It's safe to walk on. Alright. Okay, and this is the planning system where I deleted some comments and added some to-dos. Alright. Cool. So now we have physically based. And in addition to that, what else did we do? Added right, so this is, let's save this to GitHub. All right, Okay. Cool. What do you say? We will put here. So recipe table, and let's start working on the on lifting. So all these items from the temperature need to be lifted here, all the constants. Right, so what should we... So this is, yes, but I'm wondering where I should save, for example, the density table, but I can just put it in the world. So let's make a new file. Actually, I'm going to take a tiny bit break, refill my water, and then be right back, and I'll work on these things here. So just give me a second. All right. I was thinking as I was away at something, so I want to put the thing to be parallel again here. So if you guys remember, we had this thing executing on multiple threads, and now that doesn't work because I'm taking here the rendering component, right? So We're gonna do, because this is a hack anyway, so we're gonna do the following. In we can do this in parallel as well, why not? Sorry, this is like this. What? Ah, come on. Alright, cool. Copy and then paste it here. Alright. Copy paste issues. So for you know, because we're fancy, we're gonna do parallel iteration through all these rendering components. For each of them, we're gonna execute this thing that will do this. So if we have an item component, we do this magic formula. And now this temperature transfer will be executed on multiple threads, as well as this thing will be executed on multiple threads. And this needs to be a reference here, and this needs to be the temperature of the item component. Whoops, cargo run. Because I mean, yeah, I want to execute this in parallel. That's how it used to be. And right, it works perfect. And the reason it works is that we're not writing to a random rendering component in here while we iterate through these item components, right? So Rust can know at this point that the item component corresponds to a single rendering component, so we couldn't write here to that data, the rendering component. But here we're iterating through these and writing their updated values based on this thing, right? So, and we can actually lift this from this function that has nothing to do with propagating temperature to item components, and put it in another function and do it in different update slices, so they don't need to be updated each game tick. They can be updated each third game tick, as well as these ones can be updated each second game tick, so then you can like spread out your work across multiple game ticks, because this is a thing that doesn't need to be always super precise. And then, as you could see, the temperature varies slowly once we had more physically based numbers in there, because that's how physics works. All right, so let's check this in fast. Right. So this is pretty cool. Now, all right. Sorry, I got distracted because this is a hack anyway, so it's just too ugly. And let's make it a bit nicer. So let's put some smaller numbers here. You might even wonder why I don't have 0.9 and 1.1 instead of just doing this random stupid two colors. Whatever. Okay. Now it's a bit more tamed. That coupled with the fact that the temperature varies quite slowly, we're pretty good here. What else do we have? Another thing, which is we're updating the global temperature at this rate. And I wonder if we should change. So this is another hack that has nothing to do with reality. But we're not gonna concern ourselves with it. And it's funny, but as you can see, this if branch and this else branch is completely silly because basically they both do the same work. They kind of evolved to both do the same work, but yeah. Anyway, I'm getting a bit distracted, so let's put something in the world, which is should be in the world. Should it be somewhere else? Be just a constant in the temperature system. But the philosophical thing in entity component system is that systems never own data. So we're gonna do the philosophically correct thing and put here the density table, which is, what should it be? It's a hash map from a material to density value. And we might ask ourselves, well, what the hell is a material? Actually, let's put let's put everything here. This is just a string. Is it like this? Is it like this? All right, like this. So material is just a string, and I wanna add a more helper functions in here, like basically converting from so having the density and the mass and getting the volume of things. Can I take that? Yeah. So the helper functions will be here. So here we're gonna use this thing. What? Hash sap set. All right. So we don't have anything in our density table. Really? thing. Maybe missing a... What? Really? Really? I forgot how these things work actually. Private, cool. So we're having this thing. Because then it will be easy. So for example, we can invent materials and we can add new things as mods, and that would be pretty cool. Hello cat, hello again. Oh, second time my cat visited me. Usually not that friendly. I wonder what's up. Hello cat. Here. Oh, jeez. Kill my microphone. Alright, so we're having a hash set here. Oh, we're not having one because we need to use... It's a hash map, sorry. What was I thinking? Am I being tired? What's up? Also, these things, you can actually get fancy here and have proper types, like mass would be its own type and things like that. However, I will not, and everything is going to be afloat. So it actually helps if you do that with multiplying two things together and getting a new type back that makes sense. That's why you have duration milliseconds or duration types or things like that here in the standard library. What do I want to do now? Oh, actually I can... What should I do here? Should I do the same thing? Whoops. Yeah, fine, let's do that, and let's not bother with having them directly as hash maps here. Okay, so this will be a... It's like super funny, so I can't show you guys because my cam is basically stuck to my... I show you. Can't, never mind. Basically my cat is just chilling near my keyboard now, which is unheard of. So I'm highly suspicious. Highly suspicious of this cat. You do bad stuff, cat. Is that what you did? So this will be just a density table. Whoops. And this would be a... Cool. now, of course, I wonder what the hell am I copy pasting here code for? And that's because I want them a little bit contained, but I don't want to. Technically, you could probably abstract them a bit better. Right, so let's do this for now. So here in the recipes, we will have a new file which is density table, and this table will look like this. Actually, like this. This would be densities, and we will do like this: water. Okay, how many? What's the density of water? It's this. But I don't want kilograms, so I need to, whoops, kilograms. I want grams per cubic meter. So then, cool, never mind. So these, cube meter. And why is that? It's because everything else in this kind of needs to. I don't want to get into conversions of units, so that's why I'm staying with the, what are they called? International, like grams, not kilograms, as well as kelvins, units of measurement, base units, whatever. Oh, water is this. What else do we need? We need oh, we don't need this. What else is here? Do I need the density of dirt, of ground and stuff? No. Probably iron and things like that. Let's just leave water here for now. This should work technically, of course, if it would just compile. Once it compiles, it should work. By the way, can you put comments in JSON? Is this allowed? Not even sure. I wanted to mention it here, but whatever. Alright, so let's run this and see that it loads the file correctly. Of course it did not. What's up, cat? Don't press buttons. Yeah, I was wondering if Serdi allows them, because I know Visual Studio allows you to have, but I don't think the whoa, cat. Okay, sorry. I don't think the JSON deserializer from Serdi, whatever, allows me to do this. So this one actually mentions, doesn't mention anything about comments, so probably it will complain, but that would be a useful thing. Also, by the way, trailing commas, come on, why aren't those allowed? It makes no sense. Anyway, seems that this didn't work because of what? Kind, the system cannot find the path specified. What? What do you mean cannot find it? Oh, yeah, sure, English. Right. Cool. So this loads, everything's good. Everything is awesome. Now, another thing we need to have is the thinking of this thing actually. For a material, I would like to have all these properties in one place. So it's not a density table, but it's a material properties table. Right? And this will be material properties. So material properties include density, I swear to God, I cannot for the love of it remember the thermal resistivity and the specific capacity, the name of these things. It would be cool if they would allow me to put some documentation in here through comments to explain to people where these things come from and the units of measurement. Right, but that's not gonna happen. So when people, if they want to do mods and add new materials and things like that, that can be made into items, I would like them to be here. So this will be, is it like this? Wait, let me see how this should look. It is like, wait, so I have an item and then I have this, which is the, I can list the members directly. I hope that's what I understand from this. So it could be density. Oh great, I forgot the number. (997) density. Okay. Resistivity of water is, can tell you in a second, 1.6. Is this, do I need to put 0.0 because they're floats? Maybe. All right, and we also have the specific capacity water, which is 4,200. Bam, this is it. We have water. Pretty cool. Pretty cool. Rename. Boom. Cool. All right, come on. Okay, let's see that this is correct. I think this is how it should work, but let's see. Hey cat, can you not destroy my... What are you doing with those keys? Hey. Oh. Cool, so we're loading this properly and everything works fine. But we're not using it yet. So our temperature system here takes this view, and I would also like to have, by the way, let's put the mutable first and the read-only is after. Material properties table. Cool. Another thing I would like to do when I load the recipe table, I want to make sure all the materials specified in the items there have an entry in this table. Because if I only check whenever I need it, that could lead to a bit of frustration if you're changing things, because you learn too late that you forgot to add water here and get a unpleasant experience. Or your new material here if you mention it in the recipe table somewhere in the recipes. But that's fine for now. Let's add that later. So these are the material properties. And here, when we propagate stuff, we will get It's like this. What does this return get? Not like this. Okay, this does what? Probably this. The item component, of course, now has no material, so we need to add one here. So this will be a material. And the material is mandatory. Entity type. Let's put these two together here. Oh, interesting. Okay. Here we're gonna use create material. Oops. Right, so basically what this means, it will go through now we need to go to the recipe table. So all the components in my game get spawned from these component descriptors, which are basically just the data you need to initialize the component, but not all the component data, right? So for example, this entity holder has just a reference to the child entities, but the actual entity holder component, if we look at it, has more things in it. In any case, the item component needs to have a if I don't make it optional, I wonder if I should just have a default material, because basically for, let me think. I was thinking for things like berries. Or a tree. Maybe no, not a tree, but if I should just have some sort of a default material to not bother with. Should we have a default material? A bit. Because for example, let's go through our recipe table. We have milk, so this can be water. Tree, sapling, plank. Iron ore, iron bar, rock, grains. And the grains, what are these? I think if we're simulating temperature for these guys, water probably is fine for most of them. Bench, table, workbench, 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 cooking table, bench, create hole. Yeah, so this kind of item component What is this? Create hold. Oh, this doesn't have an item component. Okay, that's good. Farm doesn't have wheat, pumpkin. Whoa, thank you for the follow. You could freeze him. I misspelled it. Sorry, and it disappeared. He could freeze him. All right. Cow. How about we consider if this should be optional? I changed my mind. You know, because first of all, this file is quite big. Not that big. Maybe I should just. I need to put there. All right, let's make it mandatory. Okay, whatever. I really can't make up my mind. But I need the mass. Mandatory for sure. Oh wait, we have the weight. You can just rename this. Although now it's tricky. Because I invented some units of measurement for the purpose of, let's yeah, let's do this. We're gonna get the material, we're gonna get a mass here, and there is a bit of trickery here. Let's leave the weight in. And let's add the mass. So the reason I'm just gonna leave both of them now is because I have this concept of a container, like a bucket is a container that can take things in it, like milk. But the units it can take inside of it are basically this weight. So it can carry 10 units of milk. So 10 of these. However, the mass is something that's not. So I need to change everything to float, and then I think I need to do a bit of other tricks. Maybe just that. But let's leave it for later. I'm just gonna put a to do here. I think there's already a system that uses this. And I don't want to mess with it as part of the other thing I'm doing now, so I'm just gonna unify them a bit later. Hopefully that makes sense. And we're gonna go into the recipe and so the mass is mandatory. I'm leaving the material optional. And if you don't specify it, it's gonna just be water. Right. Because basically for temperature purposes, if you have tiny objects, it doesn't really matter if they're made of water and whatnot. Because eventually, if they're tiny, that surface will be quite tiny as well, technically. If they're lightweight, let's say. But yeah. So we can just go with water. And yeah, if we want wool and other things like that, we'll have to add it here. I just want to cause as little work as possible in the recipe table for now, and maybe later I'll just make it a mandatory property. Right, so we have this. And we should get an error when we're building the components, right? So here, of course, here we just move the terrain here, and here we have material properties. Right, and now maybe clone. And here we have to add the mass of this item. So this would be I need to delete one parameter from here, material, this is optional, and you can call that other function to set it, otherwise it gets initialized to water. This is mandatory. Looks fine to me. Fields missing, method not found. Right, so here And this should return a option of material properties. And needs the self. All right, cool. Expected 5 parameters, but 4 were supplied. What? Value borrowed after move. What? Oh, of course. So it'd be useful to actually set it before we add it. Cool. Oh, whoa, 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 what is this? What is this? What is this? Oh yeah, of course, this is a borrowed thing here. And maybe I also need to specify. And Rust figure out it depends on the self lifetime and not this lifetime. Oh yeah. Smart dude. Smart compiler. Cool. Rendering components. Not used. Right. Let's then not use them. Because we modified where we tint the color, that test code, we lifted it from there, so we don't need those components. And this color is not needed. And what's this? Freezing. This needs to remain a warning, so I don't forget about it. Alright, so now, after doing all of this thing, we can do the following thing here. So we're gonna assume this thing exists. And we're gonna use it. So material properties dot what the thermal resistivity of what of the okay. Really, you cannot find them. On what? All right, thermal resistivity, and here, what is this? Specific heat capacity. We put it here, and what is this? 60,000. What is this? The mass. All right, all right. So Yeah, why don't I put it here? Oh, yeah, of course, makes no sense to put it here. My apologies. Yo, cat. Whoop. Excuse me. Hey, Gladiator. Yes, I am using OpenGL. Yeah, just OpenGL, and I just render quads. Oh, also, maybe ended up with Golang. It's not, OpenGL is not super pleasant, to be honest. I learned it with C++ the first time, and maybe you know. Let me search. So for anyone else who's interested, I highly recommend this site. And then you can translate it to your whatever language you're using. But how do you find Golang? I think, yeah, I think no matter the language, using OpenGL is a pain, just because you have all that legacy design with the global states that are hidden from you, but also kind of not really hidden. So yeah, like setting the clipping rectangle stuff or whatever is still not great, even the modern OpenGL stuff. We need here a function. You know, I'm really conflicted about all these getters and setters, and I'm not sure what the right pattern would be in Rust. Just to make those fields public, or what? It's not bad. It's very similar to the C++ way you do it in there. I can actually show you a little bit, but basically I wrapped everything in some things like let me put this here. Maybe it's easier with getters. So I have things like shader and stuff like that, and basically in these classes I just wrapped them. I wrapped the C function calls towards OpenGL in here, like linking, attaching shaders and whatnot, and I use this in my game. Setting uniforms, just call this and whatnot. So it's not that fancy, and basically my game is 2D anyway, so I don't need a lot of so basically the texture quad is the biggest thing, and I just hardcode everything here, so vertex data and everything. And actually that can be even better, but this is an F32. But I think now if I would I'd probably go with some of the libraries which abstract OpenGL, but missing field mass. Right, so now we need to go and put mass in everything. So I started this. When I started this, I wanted to learn Rust, and I thought uh, it would be a pretty cool project. So exactly like you, basically. And it turned out to be really pleasant to use the more I used it, and I just didn't bother to switch to something like Amethyst or whatever is popular now. Also, when I evaluated Amethyst, I wrote a blog post about this. It wasn't really nice for someone new to Rust, I would say, because it was quite hard to understand some of the things. Like, why do you need to declare your components in the way they showed you in the example and so on? So I just built my own entity component system just to, learn more about Rust and how things work in it. And then I was pretty pleased with what I have, and I kind of managed to understand why some of the decisions were like that in Amethyst, for example. But also, it was not worth switching for me. And it's quite fun. Plus, I like having control over everything and defining my entities the way I do here. It's quite nice. I really like this. So just having basically a JSON file with all the data in it, and I don't care. Probably you can do this with Amethyst as well, but it just, I built something for my needs, basically. Okay, so I need to go through all of these and set the mass for the line 19 here for the item components. Should we make this optional? Should we make this mass optional? Actually, I would like to add a flag that tells you that these entities don't participate in this temperature exchange. Yeah, let's make this mass optional. All right, so I changed my mind. Of course, I changed my mind. And let's make this mass optional. And then now the fun part will be here. Because we need to specify how so of course now everything is broken for the dwarves, right? And all of these have no so for example the dwarf head, What's the mass of a human head? 5 kilograms. Okay, okay. Between 4 and 4.5 and 5, but they have big heads, so I think we should make it like wait, let's I was using as okay. So let's put it like 6 kilograms. And the material, it's water, so we can just leave it as it is. Oh, actually, you know what would be cool? No. This is getting creepier and creepier. All right, so they have something. How do I open this? Download? Or do I download full text PDF? All right, okay. So, but this is skin. So, wavelength, thermal conductivity, calories per second or centimeters. It's 10 to the minus 4. Human muscle 10. Thermal conductivity of muscle is 10. Okay, and what's the don't even know how to code. No, not really. I'm actually just copy pasting from Stack Overflow. Wait, what was this thing here? I'm not interested in conductivity anyway. I'm interested in resistivity. Where's this guy? How about you, my friend, take some time off? And code better than I can then. Alright, so where was I? Oh wait, I had it. Oh, but I don't have it in calories. I have it in joules. Wait. Let's not get confused. Wait a second. Pure water. Oh, they had it here. 15. So it's about twice. Wait, whoa. Human muscle is 10. The human muscle is more conductive than water when it comes to... That's pretty interesting. So it's less resistant then. So... This is pretty cool. I need to do a bit of math to transform this in joules. And then probably I can use this thing. Let me download this. This is great. Wait, recommended articles. I don't want this. Thank you. This is super cool. Gonna be the most useless accurate thing in my game, actually. But let's put water for now, just so we can check everything is just as before, and then I can do a bit of review of that. So I'll put here material is water. Oh, actually, yeah, run this thing. So now, if we look at the hand, wait, what did I put here? It was the dwarf head. Dwarf head. So dwarf leg, this should have 1 kilogram, basically. 1000 grams. Temperature is this. So let's remember this, 297. And the head, because it's larger, wait, what? Water. Oh, because it got it starts from 300, so that cooled off faster. The hand cooled off faster than the head, because the head. Oh, all right, so it makes sense. Cool. Now we have another inaccurate thing here, which is this distance of the heat that travels. So this works setting the material and the mass here. Another thing for the material properties that we have here is the density. So here we're gonna need something. So where's my material? Oh, okay, water. So we have the density of a material, and we need I think I actually want the volume right now. Hey, Bazu, I am building a game in Rust, which is similar to Rimworld or Dwarf Fortress, Gnomoria, and so let me show you what we have now. And right now I'm working on temperature transfer and heat transfer between my items and the world, because I want these dwarves to get cold or warm in a realistic way. So basically these are the dwarves, and you can tell them to, for example, build a campfire. They're now butchering each other because these two are like enemy dwarves. Now they're dead enemy dwarves, and they're building a campfire. You can tell them to build cake, dwarven cake. When they get cold, they go sit near this campfire. Also the cow, for example, the cow here got cold. Cow leg, 294 degrees. So this cow got cold and is just chilling here near the fire, trying to get warm. Somehow now that I changed this thing, the The temperature keeps decreasing, which is weird. What's the temperature of air here? 289. 9. It's kind of rising. Okay. Whoa, 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 whoa. 288. Ah, because every body part now has 1 kilogram of water, basically. So before it was a bit more realistic, but now I need to set some data. So what I'm doing now, I want us to calculate. So to get the temperature of something, we need to know, based on our equations here that we copied from real physics, the distance that where we measure that temperature at from the surface of a material. So to do that, I'm gonna do a tiny hack, which is for the purpose of temperature calculations, all the items in the game will be considered spheres. And you set the mass here, and you set the material from which this thing is made. And because I have the density in this other table here, I have some density for water, for example, I will know how to get, so I will get the volume of this object, and that would be the volume of, let's say, a sphere, and then it's easy to calculate the radius because I need the temperature at the center, because that's how then the other system use that information to give effects on dwarfs. Like once their core temperature decreases below a certain value, they start freezing and they need to go and find a warm place to up their temperature and so on. Yeah, so that's what I'm doing now. So maybe volume is not great here, so I will get I can just get the distance to the, I wonder what I should cache here. So if we have the mass, let's put volume here. And let's put yeah. And then I can put here muscle or skin or whatever. Now they're all made of water, but that's fine. So this will be it's a bit tricky here. What's the international? That's just basically programmer art. It's I could All right. What is this value? These are centimeters. So I need to this would be the wait, I'm just searching for something. Yeah, so this is I think this should be meters. Right. So each time we're setting either the mass or the material, we need to recalculate the volume and the distance to center. This doesn't really need to be remembered here. So not this is one thing. I'm having an internal debate on how to rename this, but whatever, let's make it more accurate. So whatever, kind of clear. So now we just need, so we have the so setting the mass triggers this, as well as setting the material will trigger this. Where is this? Right, so oh, this isn't good. This isn't good. I need the material properties here. Which is actually not too bad. What is this material properties? Yeah. I wanted to not have to do this, but I kind of need to because I need the density from the material properties, you know. Oops. All right. Cool. So now it's not super great, but it would actually help us. So here we need to do the following. So oops. We have density and we have mass. Sorry. So density is mass per volume. So volume is this, and then so this will be, so this will be the volume of our sphere, and what is it, pi 3/4? What was what's the formula? So the sphere volume is 4 over the third, so we need a radius. So radius is 3 times volume over 4. That's correct. 3 times volume. Yeah. Right. So what is it? F pow? Pow F? Whatever. Try all the things. Right. So this. Wait, where is pi here? How do I get pi in Rust? CF62 const pi. Let's put this here. Four, three. I think this is fine. Right, so okay, we did this thing so we can have the radius here in the temperature system. And instead of hard coding this distance that we need, so this is the resistivity times the distance that the heat must travel to hit your place that we need, and this will be item component get radius. Okay. Why are you attacking me, cat? Oh, what's wrong with you? It's crazy. My Jesus Christ. Stop clicking my mouse, cat. My cat is just attacking my mouse, so it's just, hey. You know what? You know what? I'm banning you from my desk if you're doing this. Right, so let's run. No. Let's run again. And again. What? Oh, whoa, 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 whoa. This is just a reference. All right, all right. Yeah, so why this is convenient is because when we create here, I will also need let's get this out of here. So basically this is why this is quite convenient, because now I don't need to really cross format, nothing. All right, whatever. So I don't need to specifically, I wanted to write a test, so whatever material properties you'd specify in this recipe table, if you do like a typo and you put water with 2 R's, oh, that's why this guy didn't wanna, sorry, this is actually Stop biting my mouse cable, please. Thank you. 100. Oh, okay. Never mind. It compiled. So probably now it can. Maybe not. All right. I was expecting I could like make this prettier, but okay. Right. So you see, here it should tell us you forgot to add material protein for the right. So it will tell us that, whoops, cannot be formatted. Really? Really? That's not an option. Why is that an option? Sorry. Sorry. Alright, so now it will crash with a nice error that water doesn't exist. Okay, so that's cool. So we'll learn as fast as possible that we made a mistake in our data entry, which is what I wanted. So yeah, let's check that for our head. What numbers do we have here? Radius 0.1 is meters. Yeah. 6 kilograms of water. All right. The way to test this would be to put 1000 grams here. I think it's actually maybe wrong. What's wrong? 0062. No, it's correct. It is perfectly correct. Oh, sorry. 6 kilograms. Right, so this is really cool because we have nice and realistic temperature transfer in place. All I need to do now is, so let's see, dwarf hand, this technically is just 1 kilogram of water, 298. It's getting colder because the terrain cell is at 297 to 98, right? So it's pretty cool. There is another thing that needs to be simulated, which is, I actually didn't think about this, but it's not really fully correct what we're doing, but we need to take into account that, for example, you get temperature transfer between your limbs as well. So that's also a factor that needs to be used here in the temperature system. Also, what is this 1.2 area? Do I need this here? I don't need this. So uh 4 PR squared. What was it? Pi const pi 4 pi. Right, so we have this. Right. So we're also zero zero 0.048. I'm thinking of lifting all of these things in different struct just for convenience, but we're good. I want to rename this to right. So now in the temperature system, we're getting the area and all of those data points, and we should be good. I was thinking maybe I shouldn't do temperature transfer between limbs, but all of them will generate temperature at a given ratio. Whatever, we can complicate this as much as possible. I don't think it's needed to simulate that, but if we need to, it's quite easy because we need only the properties that we already have, and we need to plug them into some equations that we already have as well. So, and also this takes only the air temperature. For example, we can make it that the feet take ground temperature as well. So if you walk on ice, it's different than walking on with and without boots and so on. In any case, we removed all the magical constants from here, and there are now magical constants in here, which is way more convenient because I can modify them and they can be modified by people who want to, you know, mod the game and add new items, new things. Let's see the dwarf head. Right, it's this. Okay, cool. And what if the head is 1 kilogram of water? I need to check this matches. This is correct. Cat, what are you doing? Yep, all good. It is all good. Put it back to 6 kilograms. And basically, I can be as thorough as I want in this, because we actually found earlier What? Sorry, I needed to... Dwarf head. Okay. And the ambient temperature is about... Well, I can't tell actually. It's probably 15 degrees, so it's 273 plus 15, 288. So the ground temperature now is decreasing, but also this guy's head temperature is decreasing at a reasonable ratio, I would say. It's kilograms of water, you're at 15 degrees from... I can't think in Kelvin, so from 27 Celsius, 27 to 15, and each game tick is about 5 minutes, I believe. Yeah, seems good. Cool. So this is turning into a very precise simulation of temperature and transferring energy and stuff. You can even see the color multiplier changing slightly as they get colder, which is pretty funny. And we can build a campfire here because soon they will be too cold. Is any of them warming up? No, they're just idle. And the beauty of these formulas that I mean, this is how things work, is that the thermal resistivity is additive. So if you have layers of things, you can basically just do a sum and over the total thermal resistivity to compute it. There's this really nice book here that explains it. For example, let me show you one thing before I'll head out soon because I kind of did what I needed to do and tomorrow I need to go to work. But for example here, so the total R value, which is the thermal resistivity times the distance the energy travels, is basically, it's composable. So you have more materials on you, you'll just sum them up and it just works. So you'll get a total R value of a wall is the drywall plus insulation plus whatever, which is pretty neat because when these guys will have clothes on them, they will, it's very easy to make it work with clothes, right? Because you just build like here a loom. This is kind of cool. I like what we ended up in the end, and I'm happy I went with the proper physically based stuff rather than just inventing formulas, because I would have to then tune up invented formulas, whereas here I need to tune them up anyway, but at least we start from some real life things. So you can put a cloth shirt on you and then you can get a different thermal resistivity that gets plugged into this formula here in my temperature system here. So instead of doing this, we need to do a sum over all our armor items, and that's very easy to get, and I can add that next time when I stream or whenever. Now they're just like here trying to get themselves warm, and we can even see that. Let me move some of my debug windows. I need some better menus, but we can see their heads, for example. 298. Well, they're going down. Are they going down or up? Wait, sorry. This doesn't yet work because... because the dwarf has its own temperature here. So this is wrong. I need for an entity that's made up of body parts, like dwarves and cows and stuff, I need to compute this for each body part instead of once per entity or whatever. In any case, that's pretty cool. We can actually do it here if you want. We can go to here and but the nice thing about this also is that they can have proper frostbites. So if you have just pants, like let's imagine these dwarfs have pants, then their arms can get frostbites and they can get damage and eventually need to be amputated. I can have a per limb effect. So I need to extend this system so it takes into account the body parts, but that's pretty easy. All right. In any case, if you'll have questions, I'm happy to answer them. If not, let's find someone to... Do you have enough people for a mini raid? Some people here still. Okay, let's see who's online. All right, let's go here. C++, music, shaders. Cool. So thanks all for watching, and I hope you had a good time. I'll see you all next time, which is probably next Sunday at 7:30 GMT in the evening. Bye.